Everyone, welcome back to another chemistry lesson. Today, we are going to understand the periodic table of elements in a very simple way. Many students think the periodic table is just a full of chart full of symbols and numbers. But actually, it is a well organized map that helps us understand every known element and predict how elements behave. By the end of this video, you will understand how the periodic table is arranged and why it is one of the most important tools in chemistry. So, what exactly is the periodic table? The periodic table is a chart that organizes all known chemical elements. Elements are arranged according to their atomic number, which is the number of protons present in an atom. Elements with similar properties are placed together. This makes it easier for scientists to study and compare them. The periodic table helps us understand reactivity, valency, electron arrangement, and many other properties of elements. Every element in the periodic table is represented by a small box called an element square. Let's understand what information this box gives us. At the top, we have the atomic number. This tells us the number of protons in the atom. In the center, we see the chemical symbol. It is a short form of the element's name. Below the symbol, we have the element name. At the bottom, we find the atomic mass, which represents the average mass of the element. By looking at the single element square, we can learn a lot about that element. Now, let's talk about groups, also called families. The vertical columns in the periodic table are called groups. There are 18 groups in total. Elements in the same group have the same number of valence electrons, which are the electrons present in the outermost shell. Because they have the same number of valence electrons, elements in the same group show similar chemical properties and react in similar ways. The horizontal rows in the periodic table are called periods. There are 7 periods. As we move from left to right across a period, the atomic number increases one by one. Elements in the same period have the same number of electron shells. For example, all elements in the period 2 have 2 electron shells, while all elements in period 3 have 3 electron shells. Group 1 elements are called alkali metals. These include lithium, sodium, potassium, rubidium, cesium, and francium. All these elements have one valence electron. They are highly reactive and readily lose one electron to form positive ions. Their reactivity increases as we move down the group. Group 2 elements are known as alkaline earth metals. They have 2 valence electrons. These metals are reactive but less reactive than Group 1 elements. Examples include magnesium and calcium, which are important for living organisms. Group 3 to 12 are called transition metals. These include iron, copper, silver, gold, and many other useful metals. They are generally strong, shiny, good conductors of electricity and widely used in industries. Group 13 contains elements such as boron and aluminium. Most of these elements have 3 valence electrons. Aluminium is one of the most common used metals in everyday life. Group 14 contains carbon, silicon, germanium, tin, and lead. These elements have 4 valence electrons. Carbon is especially important because it forms the basis of all known life. Group 15 is called the nitrogen family. These elements have 5 valence electrons. Nitrogen makes up about 78% of Earth's atmosphere and is essential for life. Group 16 is called the oxygen family. These elements have 6 valence electrons. Oxygen is necessary for respiration, while sulfur is widely used in industry. Group 17 elements are called halogens. They have 7 valence electrons. Halogens are highly reactive nonmetals and easily gain 1 electron. Examples: fluorine and chlorine. Group 18 contains the noble gases. These elements have a complete outer electron shell. Because of this, they are very stable and generally do not react with other elements. Examples include helium, neon, and argon. At the bottom of the periodic table, we find 2 special rows called lanthanides and actinides. These elements are placed separately to keep the table compact. Many of these elements are used in electronics, nuclear energy, and advanced technologies. So that's the periodic table in a nutshell. The periodic table is not just a chart. It is a powerful tool that helps us understand the structure and behavior of all elements. Once you understand groups, periods, and valence electrons, learning chemistry becomes much easier. Thank you for watching. If you find this video helpful, don't forget to like, share, and subscribe. See you soon in next chemistry lesson.